When we look at an equation, like in example 4, y equals negative 7/4 x minus 7, another piece of information that we can pull out of that graph are the intercepts. We've already talked a fair amount about the y-intercept, which is represented by that value b if our equation is written in slope-intercept form. So in this case, we already know that we have a y-intercept of 0, negative 7, and we can see that point plotted clearly on our graph. So if we weren't given the equation for the line, we would just identify that point where we hit the y-axis. We'll use that to identify our x-intercept, because right now we don't know how to pull that information out of the equation. We look at the graph and find the point where our equation intersects with the x-axis. We see that that occurs right here at the point negative 4, 0. There's a pattern here that's going to be helpful to notice for our next problem, which is that when we look at our y-intercept, the x value is equal to 0. The x-coordinate is equal to 0. And when we look at our x-intercept, the y-coordinate is equal to 0. So we always have this pattern that when we're looking for an intercept, the opposite or the other coordinate is equal to 0. And again, that's going to be a helpful pattern to pick up on when we start trying to identify x and y intercepts just from the equation without looking at a graph. But if we're given a graph, again, we just need to identify the points where that line crosses either the x or y axis.